Welcome to another video in our series Commissioning of a Varitron System. My name is Manfred Schleicher and I work at Yumo as a technical trainer. Yumo offers you the Yumo Cloud, which gives you worldwide access to process variables from Yumo systems. In this video, I will show you how to make analog values from the Varitron 500 available in the Yumo Cloud. Let's get started. First, I'll show you again what I'm planning to do. In the previous video, I put control channel 1 of the controller module into operation. For this channel, you can see the actual value, the set point, and the controller output here. I have also set up the set point so that it can be changed in a process image. I do that now. In this video, I show you how to make the 3 process variables available in the Yumo Cloud. The process variables are updated every 5 seconds in a Yumo Cloud dashboard. And now I start setting up everything I need. Tenants find application in the Yumo Cloud. They divide and structure the cloud. This section of the cloud can then be used by specific users. I open the Yumo Cloud and log in with my user ID. Now I can work with all the tenants that have been approved for my user. Here you can see the 2 tenants that were last accessed. I will now create a tenant in which we will later visualize the Varitron system and continue to give one person rights to this tenant. This person will then set up the cloud application. I navigate to the central administration. And here I create the tenant. I give it a name. I want to transfer 3 signals to the cloud. And these come from a Varitron system. So I set 3 signals and 1 data source. Now I select who is allowed to work on this tenant. I do this by inviting the person to this tenant, and this is how it works. The employee must be registered in the Yumo Cloud, and I enter his email address here, for example. Here I specify the employee's administrative rights, for example, whether he is allowed to create tenants and invite employees to them. The employee should have access to the administration, however he is not allowed to change it. Here I specify the extent to which the employee can access the tenant's configuration and dashboards. I grant the employee all options. I send the employee an invitation to this tenant. Finally, I log out the current user from the Yumo Cloud. And now I log in with the user who has just been invited. Here I confirm the invitation and then the tenant is available to me. I will now create a data source which will be later my Varitron system. The cloud will provide me with a device ID and a password. I will enter this information in the Varitron system in a further step. There be connection the system to the Yumo Cloud. I navigate to the tenant configuration and create the new data source. I give the data source a name and specify that live data, such as current measured values, should be sent to the cloud every 5 seconds. After saving the settings, the device ID and password are available to me. I copy the password to the cache. I now have to enter the device ID and password in my Varitron 500 system. To do this, I start the web cockpit. An option must be available in the CPU for the cloud connection. This is the OPC UA server from Codesys, and here I can see that it is available. Now I enter the ID and password. I activate the Cloud Gateway, enter the device ID, and enter the password. I select Save and the settings are transferred to the CPU. The CPU should send the actual value, the set point and the controller output to the cloud. I have to specify these variables in the codices. So I go to Smartware Setup Varitron in my existing project and start codices from there. The actual value, set point and controller output of the first control channel must be mapped and called up at least once in a program. Here I show you that the actual value is mapped. I also know that I have called up the actual value in the main program. Here you can see the mapping for the set point. I have also called this up in the main program. The controller output has not yet been mapped. I will do that now. And I call up the variable in the main program. To make the three variables available via OPC UA, I now create a simple configuration. Before I can select variables for transmission, I generate the program code here. And here I can see that the program is error-free. Now I select the three process variables for transmission: the actual value, the set point, and the controller's output. I transfer the program to the CPU and start the program. Now I switch back to the cloud and continue configuring the tenant. Thanks to my previous settings, there is now a connection between the Yumo Cloud and my Varitron 500. The Varitron 500 is my data source, and I send the previous configuration to it. The Edge Gateway handles the data transfer from the Varitron 500 to the Yumo Cloud. I have to tell it which protocol to use to access the data on the Varitron 500. In my case, it's OPC UA. I now define the communication path for the data source, respectively for the Varitron 500, using a new data connection. I name the connection and I select data source. To find the data source, I specify here which tenant it is located in. Then I select the data source. Access is via OPC UA. To reach the Varitron's internal OPC UA server, I enter its URL here. I have to send the settings for the data connection to the Varitron 500, which I will do now. Now I make sure that the actual value is transferred and displayed in the dashboard. I create the actual value as a signal to be transferred. I name the signal. Because the actual value is transferred to the cloud, it is an analog input. and it comes from my Varitron 500. I select the data connection via OPC UA. I had previously selected the actual value in the simple configuration of codices, so I can select it in a browser as follows. I select the unit degree Celsius and save the signal setting. I also have to send the configuration changes for the signals to the data source, which can also be done directly here. I will now create a dashboard, create a tab for this dashboard, and then place my actual value in this tab. I create the dashboard as follows. I name it and save it. I need at least one tab for the dashboard before I can place a widget in it. I create the tab and give it a name. I save the tab and then save the dashboard again. Now I will place a widget with the actual value in the dashboard tab. I am here in the dashboard system 1 and here in the dashboard tab PVSP out. I start editing the dashboard. I create a new widget and determine its size. I edit the widget. The actual value is a single signal. I name the widget. The header of the widget should also be displayed. I select the actual value as the signal to be displayed. Then I save the widget and finally the entire dashboard. I can see from the timestamp update that the transfer is working. Now I take care of the set point. I also create this as a signal and name it. It is also an analog input. I specify the data source, my Varitron system. The set point is also transferred via OPC UA, and I select the set point from the variables made available to me via OPC UA. The unit for the set point is also degree Celsius. I save the signal and transfer the changes to my data source. I create the signal for the controller's output level. I name the signal. This is also an analog input. It comes from the same data source and via the same data connection. And I select the output level here accordingly. The unit for the output level is %. I save the changes and transfer the settings to the data source. I now place the setpoint and controller's output in the dashboard. I start editing my dashboard and create another widget for the setpoint. The setpoint is also a single signal. I name it. and I want to display the header for the widget. I select the set point and save the widget. In a quick run, I now create the widget for the controller's output. And so the 3 signals are available to me in the cloud.